Alright, welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. We are still implementing unassemblize tool, still busy with the assembler matcher class, which has been keeping us on our toes for a couple of videos already. Especially here the comparison between the ASM instruction with the look ahead logic. It is really quite something. Okay, so where did we drop off? Right, there is problem with ASM mismatch detail here. So this one is disregarding the jump length. Good. So we have mismatch detail, compare ASM text. Okay, so here is mismatching to look at. Is jump. Mismatch detail. Good. Okay, so ASM mismatch detail. And the information about mismatching jumps is also in here, right? I mean, the simplest change would be to just copy that condition to the look ahead logic, right? This one. So we have this mismatch. But it would be nice to make it a little bit uniform. Mismatch. Okay, but we cannot get hands on this information because we don't have ASM instruction for the opposites. Let me see. So we would need to pass on we would need to pass on this one here. Okay, so we would need to have this thing here. Wow. Let's put this up here. Let's put new or next variant. Or let's say updated. Wait, what we can also do is we can put this back here. And then we can move this one. Move this one in here. Right? And this way we will have access to a variant 0 and 1. Yeah. Let's stop the debugging here. So we need to pass variant 1 here. And actually we need to pass instruction, not variants. Instruction 1. And here we need to pass instruction 0. ASM instruction. Assert is matching. We assert instruction 0 is not null pointer. Instruction 1 not null pointer. Okay, and then we pass. Let's dereference it. Okay, let's pass it as base IT. Look ahead. So we pass it as ASM instruction opposite base instruction. Right, I think this will work. Opposite base instruction. Okay. Okay, and then we need to say opposites base instruction, base array, last IT, base IT. I'm trying to think of so this ASM mismatch detail, this one is just for the text, at least this one. This here is just for text. Maybe we should clarify this mismatch. ASM mismatch detail. ASM text. ASM text mismatch. ASM let's call this ASM text mismatch info. Mismatch bits. Maybe we should call it mismatch text info. Text mismatch text info. Mismatch text info. Or we just call it text mismatch. Text mismatch. Yeah, let's keep it. Then we call this text. Text. Well, it's kind of misleading. Because one would imagine that this is a string now. Maybe call it text info. Text info. Okay, let's create a new static function. Static bool is jump mismatch is jump len mismatch, and here we pass this instruction 0, instruction 1. And there we simply say return jump is jump and instruction 1 dot is jump and instruction 0 dot jump len is not jump 1 dot jump len. Yeah, simple enough. Is jump len mismatch. Okay, and then we say here mismatch detail. Mismatch. Let's call this text info. Text info. Okay. Is jump len mismatch. Well, the English is a bit bad. Maybe we should say has jump len mismatch. we moved this earlier, but I think we can put it back in. Return not is matching. Okay, so what we can do then here is has jump len mismatch. We rename this to mismatch. Is mismatch. Maybe we should rename it to mismatch bits. Let's call it is mismatch. Is match. Keep it simple. The shorter the word, the better. Okay, so here we say has jump len mismatch, instruction 0, instruction 1. Yeah. Mismatch detail. I wonder if we can combine these two things somehow. Like already here, this I don't like that they are so decoupled, you know? Okay, I will be right back. Okay, we are back. Good. So it would be really nice if we could combine these things somehow. Okay, but we can only dereference it afterwards here. And here we already do the check before. Is matching. Do look ahead false. Is matching look. This mismatch detail thing is only used here. Text info. It's I I think we can. I think we can move this here. I think. Mismatch detail. Breakpoints here. I don't like this flow here. I mean, it's legal C++, but it's so hard to read. Actually, it should be all these three things combined into one. Right. Strictly speaking. How can we do this? But we still also want to get this out of it. I think I have an idea. We create a new static bool has mismatch, and there we pass these things, and these things as pointers, and we pass this here, text info, this text also as optional text info. Okay, it's quite a mouthful. Okay, but it is an idea. It is an idea. So if we go to here, let's take all these guys. Has mismatch. Okay, so we do if has mismatch. So if instruction is invalid, does not match the other invalid, then return true for mismatch. Oops. Else if Okay, then we do mismatch. Text info 2 equals that. Text info 2. If array 0 is not null pointer and array 1 is not null pointer, then text info 2 is compare the reference like that. Otherwise, do text info 2 with instruction 0 dot text and instruction 1 dot text. And then we have this if text info is not null pointer, then text info equals text info 2. And then if text info 2 dot is mismatch, then return true. Else here, if it has jump len mismatch, instruction 0, instruction 1, then also return true. And only then, if all this has passed, it's return false for no mismatch. Has mismatch. So if one of these is invalid, mismatch. If both are invalid, then it's a match, right? Strictly speaking. Then we get the text info. I don't like that we called it text info 2. Let's give it some other name. Let's call this out text info. Okay. Yeah, I think this works. Has mismatch. Okay, and then this means that here we can go ahead and we can remove all of this. And we do else if else if has mismatch. And here we pass instruction 0, instruction 1, array 0, array 1, and mismatch detail. Huh, interesting that it doesn't format this here. I don't know what's going on here with the formatting. What's wrong here with the formatting? Oh. Okay, and this should save us from all this here. Has mismatch. This, yeah. Has mismatch. Can give a default arguments here, null pointer, null pointer. Let's put the stupid clang format here. Okay, I think this is pretty good. And now we can also use it here. So we have this text info, and then we do has okay, if not has mismatch. So we put look ahead last IT opposite base instruction. Const ASM instruction look ahead last instruction equals std get instruction that so it should be here, look ahead last instruction, and then look ahead last array and opposite base array. Opposite base array. If not has mismatch. Yeah, I think this is correct now. It's matching with base on the other side. Okay. Okay, but now we have a problem here. This text info is not filled. Text info, ASM mismatch. Because you put a dummy instruction there. Text. I think we can text mismatch info, text info, text info dot mismatch bits. We just set them to 0u. Uint 16 T U Yeah, so basically we just mark all, we just set all mismatch bits. Then what we can also do is we set all bits here. No, here. Text info. And we also text info dot mismatch bits equals un16t0 mismatch bits. This looks much simpler now. Yeah. Okay, that's cool. That's cool. Has mismatch. If not has mismatch, is matching true. Mismatch. Look ahead last. Yeah. Okay, I think this is correct. Boy. Mismatch bits. Okay, I really like that we now have one function to check for mismatch, where we pass the instruction pair, and then it checks it. Yeah. I just don't like that we have so many arguments here, but what can we do? 7 arguments here. It's quite a lot. Okay, but it is kind of readable. Yeah. It is kind of readable. Okay, now the question is, do we get closer here to a functional setup or not? We can also remove this here. Now I do wonder, can we do anything here to increase readability? Pairs and text. Let's call this info or results. Okay, let's remove all this stuff here. Wow, this function. Yeah, okay, well, the function is not so long anymore. It was longer. It's good that we have a bunch of stuff in here. Yeah. And in here now. Okay. Let's compile. Okay, it compiles. Good, then let's take a look at some results. Is matching false? Is matching true? Okay, here we have a matching function. Let's see. One, everything is one. Great. Push ECX. Push ECX. Okay, let's have a look at the next one. Is matching false? Okay, let's see. What is mismatching? What is mismatching? Yeah, this is mismatching. This is also mismatching because the name is slightly different. Need to see what's up with that. This is also mismatching because of the name again. Okay. Oh, what's going on here? Why is this empty? Huh? Okay. Dummy instruction. Okay, here we have different jump size. Also different jump size. different offset size. Yeah, interesting. Let's see the next one. Also not matching here. Let's see what's wrong. Okay. I suspect this is because I compiled and debug. Maybe. That could be the reason, yeah. That's good for testing. Okay, oh, here we have a lot of mismatching. Oh. What is it? Set ASCII string. Push easy, morph CL. Okay. Interesting that everything is mismatching here. That's unexpected. Next. This one is not matching. Why? I see. Okay, so again, offset is different. Okay. So this looks already really promising. Let's let it have run through. Okay, it runs through without crashing. That's good. I think there's a little bit of an opportunity here. Here, our comparison result, it says is matching false. I think what we can say is int or uint 32 t num what num matching and uint 32 t num mismatching. Uint 32 t num labels. I think that would be better information than is matching. Like here we get like, okay, how many are actually matching and mismatching, which we should be able to count as we process. Matcher is matching true. So we simply say here, oops. So we say result dot num mismatching plus plus. Okay, and here we have num matching. Yeah, ASM match, ASM mismatch. And here we have a label. Here, num label. Let's call this differently. Label count, match count, mismatch count. Label count. Mismatch counts, match counts. Okay, here is also mismatch, mismatch count, plus plus, plus plus. Dot label count. Mismatch count, match count. Okay, we need to check if we have added it to all this. Match count, mismatch count, label count, mismatch count, label count. Yeah. Okay. Let's see if we get good numbers there. We need to put a breakpoint here. I just realized that the debugger, so to say, is our UI, right? If strictly speaking, the debugger is currently our UI to test like if we get good results that look good, right? So yeah, strictly speaking, the debugger is a UI. It shows us the values, the results. Yeah. Good. Let's see results. This makes sense. So if we count these together, does this equate to the total number? 466 plus 39 plus 6. Yeah, it does. Okay. Label match count 26. Match count 39. Mismatch count 7. Label count 2. Match count 6. 1. Yeah, this looks really nice. Very nice. Very nice. Okay. This is pretty cool. I think we have done really a lot of changes now. It's time we start submitting this. We have something that appears to work. Let's review this and push it if we like it. Okay, but first we need to clean up. Yeah, I think the code is pretty clean for the most part. Maybe there's a little bit of dirt, but it all makes sense. This one is a little bit overcomplicated, I feel like, but it seems to work, so I guess it matters. That's all that matters. I want to. Let's put a breakpoint here for condition in quotes equals true. I want to see if that works. Huh, it never hits. Huh. Which to me indicates that this doesn't work as expected. So it cannot leave a quote then. Yeah, this is still wrong, I think. This is still wrong. Let's think this through one more time. Okay, but before we do that, let's clean up other parts that need cleaning. Function.header. I think we should rename this to variant vector. It's quite a bit long. Variant. Or we call it variants, plural. Okay, remove this. That. Okay, it's quite a lot of stuff. Okay, we need to can also clean here. Run comparison, clean this. Text array. Instruction. String. Text string to text array. Let's rename this to arrays as well. Okay, let's get back to this algorithm once more. This one is hardcore here. So basically, the problem is here. Wait, condition. Oh, in quotes. Oh, I set the wrong condition. In quotes, larger than 0 should be larger equal than 0. Okay, let's run this. Okay, that hits. That's good. So the word was ensure unique buffer. Yeah. And so this will in quote -1. So we leave the quote and then it continues and then it should be at 0. Yeah. Just exited. Good result. Mismatch bits. Okay, no, so it actually does work. It does work. Okay. Let's put a breakpoint here. In quote 1, skipped both. Why? Lock, yeah, both ripe for skip. And if they were, if one of them was skipped, then in quote -1. This match ++ exits. Check if strings are entering a quoted symbol name. Let's add some more comments here. If skip ahead unknown symbols such as unk, or let's say off. Yeah, unk A B C D. 1 2 A B. A0. Okay. If just one, if one side skipped an unknown symbol, then skip the other as well. If one side skipped an unknown symbol, then skip the other as well. Then skip the other symbol as well. If at least one symbol was skipped, then this quote is done. We can actually also add an assert here. Assert char0 equals quote, right? And char1 also equals quote. And here we expect char0 and 1 not to be a quote. Yeah, I think this will help us. Can we check if strings? Let's put here string is entering or leaving a quoted symbol name. This section is mismatching break. Okay, I hope this helps explaining. Yeah. Okay, let's run this through to verify that we hit none of these asserts. Hit none, no assert. Very well. Okay. Cool. This appears to work very nicely. Yeah, let's see if there's any dirt left that we need to remove. I don't quite like the Clang format stuff. Let's change the okay. Creates all instruction splits in advance to avoid redundant splits when visiting instructions multiple times. Let's add some more comments here. Check for any labels. Check for missing instruction. Check for missing or mismatching instruction. Check for missing instruction on either side or mismatching instructions. And mismatching instructions. Check for missing instruction on either side and mismatching instructions. Look ahead instructions to check if there is a match further ahead. Look ahead takes turns on both sides. The first look ahead match will determine the side that skips ahead. Skip over label. The first look ahead match will determine the side that skips ahead. The new base index. You can add a comment. Is expecting these are all mismatches because above it hit the first match upon look ahead. Insert the label and go ahead. Okay. I hope this class is quite a bit heavy. It's a bit heavy. The logic, it's not a big class. I mean, 400 lines of code for this matching logic. I think it's not too bad. I mean, yeah, it's not little, but it's also not too much. Like too much would be like 3,000 lines of code for matching, right? That would be quite complicated. But 400 is within the realms of expectations, I would say. Yeah. Okay, well, it looks pretty good. It looks pretty decent, yeah. Okay, then... Yeah. Yeah. I don't quite like this here. I mean, it was already bad enough before, but now it's even worse. What we could also do is we can format this with a format library, and then do it that way. Yeah, here is the style. We do it this way, and then we just pass it on here. Here. That would make it a bit easier, I think. Yeah. We can do that, yeah. Okay, here we got some more comments. Here. Instruction null. Do we actually use it now or not? Yeah, null instruction variant. Null instruction variant. Yeah, okay. Good. I think it looks very good. Apart from apart from here, these strings here, this is very hard to read, so we make a pass on this. Yeah, but let's take a break now. It has been 1 hour 40. Let's take a break and then we do this afterwards. Yeah. All right, I hope you enjoyed it. Wish you a great day or night. Until next time, goodbye.